Let's do this. Um, Today we're going to be covering elementary programming. And it's really the very basics of actually doing programming. A lot of what we did in our first lecture was really talking about what Python is as a programming language. What programming languages do, how we solve problems with them, a little bit of history with people like Grace Hopper. But it was really not teaching us how to program. Today we're going to learn how to do some basics of programming. So as we get started, I want you to go ahead and open up in another window on your computer. Go ahead and open up another window with repl.it as your address. And I'll help you get there later on, but we'll just go ahead and have that up. I'm sure most of you have screens that can fit both the Google Meet window as well as the repel.it window. So that'll help us out whenever we actually get to the coding part, but we got a little while. So I'm going to go ahead and present here, and I'm going to show you the next PowerPoint slides. This is topic 2, elementary programming in Python. All right, so there's something about Python that needs to be understood. It is a high-level language, and that means that it's English-ish, all right? So we can follow it along pretty well. The purpose of a programming language is to solve a problem by giving a set of instructions to a computer. Okay, here, take this number and add it with this number and then print it to the screen. It's these very detailed sets of instructions. That's what the programming language is supposed to do. But as we remember that computers are super, super dumb, and we have to really kind of work our way into talking to them in their language of zeros and ones, we use these programming languages to do it. But the thing about it, the reason I say English-ish, okay, it's not the same as English. It's not as descriptive as being able to speak to your computer as I'm speaking to you. It has to be a little bit more detailed, and it can look really tough and mathy and all this stuff. But we can do it. I want to give an example of this in the next slide. And I want you to take a second to read this program, okay? Now, I haven't taught you any Python. I've told you what Python is, but I haven't taught you any Python. Now, if you can read this, okay, I want you to take a step and go line by line, step by step, and review exactly what this program does. Now, if you aren't familiar with the show Step by Step on the right-hand side, that joke is a little bit for people of the 80s. Ask your parents about it, and they'll tell you that they're very happy that they don't have to pay for this class. All right. All right, just going line by line, you're reading a somewhat advanced Python program. We won't learn how to write this stuff for another topic. Next week, we'll begin to learn to write this kind of stuff. But you notice how you can kind of figure it out. On the first line, it says Python program to check if year is a leap year or not, with a like a little hash thing there, okay? Then it says the year, and then it has the equal sign 2000. And then it says this stuff. Oh, I don't know what this says. If the year and then it's a percent sign 4 is equal to 0, can anybody give me a guess what that might mean? What could that possibly mean?
Doesn't the percent sign stand for remainder of?
Yes, remainder of, and that's super advanced. But I would let me see. I'm trying to open up my chat here.
I'm not sure what it means, is if it's saying remainder of 4, or if year divided by 4, the remainder has to be 0.
Awesome, but you're kind of there, because how do we know if a year is a leap year?
If it has that extra day.
Yeah. So that's like, if we know it's a leap year, and if it's a leap year, it has to be 366 days. We add 1 to February. But do y'all know how we determine whether or not a year is a leap year? If it's divisible by 4.
Isn't it every 4 years?
Every 4 years is there. So oddly enough, we can already start to kind of understand this program, even without understanding it, because Zach, you're absolutely right. The percentage sign is actually called the modulus or the remainder operator, and we will definitely talk about it. But it's kind of an advanced topic. But look, if it's divisible by 4, if it's divisible by 100, if it's divisible by 400, then it is a leap year. Otherwise, it's not a leap year. Otherwise, it is a leap year. Otherwise, it's not. Okay, now we don't understand this code exactly, but does it look English-ish? Does it look like you can kind of follow the logic in a step-by-step fashion? That's what English-ish is. We don't understand this program. I haven't taught it to you yet. All right. So we don't understand it, but at the same time, we get the general idea, we get the step-by-step nature of it and how it's trying to talk to a computer. So what we're going to hopefully get to is we're going to be able to write some of this English-ish, and we're going to start giving it some instructions. We're going to give the computer instructions today. All right. So first off, I have to teach you a vocabulary word. And the vocabulary word I'm going to teach you is syntax. syntax. Now, syntax, if I'm giving you the definition, is a set of rules that define a language, whether or not it's English or Python or languages like C++. It defines the rules it's the rules that define the language itself. Now, this is our means for giving instructions to the computer in a way that it can understand it. If I were to, kind of give an example of English, consider this sentence: jumped over the moon, the cow. It has all of the necessary components to make it an English sentence. I see a subject, I see a verb, I see whatever that thing at the end of the sentence is called, like the predicate or whatever. They're all there, but they're out of order, so it's nonsense. We have no idea what's jumping over what. The moon cow? I don't know what that is, right? If we don't follow the subject, verb, predicate direction, the meaning of it goes away, and we don't know how to interpret it. So our syntax, the rules that we have to follow, are very detailed, because remember, computers are super dumb, okay? Ridiculously dumb. You will have it so close, it'll be right there, and the computer won't understand it because you didn't hit tab somewhere, right? It's just really, really dumb. So we have to be very careful, all right? So we're going to start learning the very beginnings of syntax today, and we're going to have a whole nother lecture in between, but we'll see how far we can get today. All right. So the first bit of Python syntax I'm going to give you is also the easiest, and that is the comment. Now, comments are lines that start with a character that's right there, all right? So what do y'all call that character? Hash? Pound?
Yeah,
No?
pound sign.
Pound sign? All right, I can call it that. I could also call it the octothorpe, which I think is the actual name. I definitely can call it pound sign if that's what we're most comfortable with. So what this does is this is a line of Python that doesn't give an instruction to a computer. It doesn't. It's not telling the computer to do anything. Instead, it's a way to tell the programmer something. It's a way to like make a little note in a program. Now, sometimes it can be complicated, and we'll see this. You can have inline comments. Like on number 2 there, you can see print hello, and then a pound sign, and it says this neither. It ignores Python. The computer ignores anything that's on a line with a hashtag in front of it, or with a pound sign in front of it. And you use as many of these as you need. Now, this is just super straightforward, and I'm going to just keep that in your noggin, and we'll move forward to the next one to show it. I'm going to try to avoid all the cheesy jokes that I possibly can. Hashtag keep it professional. All right. So moving to the next slide. All right. Let's get into our next big topic. Okay. This is a topic that I love to talk about. In syntax of a language, they have to have something called memory, a way to have storage. And the means by which we store things in a programming language, they're called variables, okay? Now, this is an analogy, but it's a very real analogy. Okay, it's not it's one-to-one. All right, it's not far-fetched. It's very similar to a safe deposit box. All right, when you walk into a bank and you've got a safe deposit box at that bank, there's loads and loads of locations in which we can store data. How do we know which one of those safe deposit boxes belongs to us?
Assigning it a number or a name.
Yeah, usually there's a number right there, and that helps us know exactly which one. So we know that we're safe deposit box E7, all right? And once we're there, we know exactly which box it is. Now, here's the thing. Computers store data in the exact same way. If you've ever heard of the RAM of your computer or even hard drives, all that is a collection of safe deposit boxes that are very, very small bits of information. Let me go back to my window. These things have all the same stuff that a safe deposit box does. First, it has a place to store things, which is just a series of little zeros and ones, not super important. But what's most important about it is that they have a name associated with it, a name. The second is that they have a value that can be held in that box. And third is that they have a type of data that it stores. And I'm going to talk a lot about what that type is. Okay, a lot about what that type is. All right. These three things together help us understand storing things from a language perspective. And this is like we start at square one because this is the most important thing. It really is. All right. Everything works off of variables. All right. Before we get there, let's understand data types. There are different types of data, and we can tell what those data types are. Okay. We really can. All right. So let's imagine a very real scenario. Okay. So I'm going to pick on you. Carter, can you see me? All right. Carter, you're going to a party and you see this really attractive person across from the thing there. And you're like, yeah, go over there, talk them up a little bit. And you ask for their phone number. All right. And they write something down on a sheet of paper, they fold it up, and they hand it to you. And the phone number they give you is 985-555-815. Carter, what does this mean?
They didn't give me their phone number.
That means that you are single, buddy. All right. This did not change your status at all. See, we know that something's missing. We expected a piece of data to have a very consistent form. We expected area code, exchange, and number. And we knew exactly how many pieces and parts go into each one of those sections. Data types have that defined characteristic. Okay, so let's look at the first and the most obvious of the data types. All right, the first type of data that I'm going to talk about is an integer data type. Integers are very simply whole numbers. They don't have a fiddly bit at the end of like 0.14159, any of that stuff. Okay, so examples of this, like the number 42 with no partial bits after it. The number -1 is an integer because it's a whole number, even though it's negative. 0, anything that doesn't have a decimal point and then some fiddly bits is an integer. And that's what we call those data types, right? Y'all know this stuff. It's super easy. Inside of Python, we have some other ones as well, like float. Now, float is a short way of saying floating point number. But a float data type is a number that has like a partial bit. Okay, it has a fiddly bit after a decimal place, and it always has a decimal place. So even if it's like 5.0, it's 5.0. It doesn't just say 5, it says 5.0. So some examples is 17.38, right? Or -0.2. Anything that has the decimal place in the numbers, I think they're called like the mantissa or something, right? Anything that has that is called a float, short for floating point number. The next data type that's important for Python, and especially the ones that we're going to talk about in this class, are strings, which are just like they're a string. They're like a sentence, right? A bunch of characters and numbers or whatever inside of quotation marks. So for an example, lorem ipsum inside of quotation marks, or this is a string inside of quotes. This is what Python calls a string, which is nothing more than a bunch of letters and numbers put together. All right, so like you would write down on a line of notebook paper. And the last one I'm going to talk about takes a little bit of finesse. I'm going to have to go to my longer recorded lecture for this to talk about the Boolean data type, but a Boolean data type only has two possible values, true and false. Zach.
So for the strings, when would you use the double quote and the single quote? It didn't seem to matter whenever I was actually like doing the assignment.
That's a great question. The answer is it doesn't. I usually use double quotes whenever possible, because if you try to use like a contraction inside of your sentence that you're writing, it'll match up the single quotes. So basically, if my string has a single quote in it, I go ahead and use double quotes. And that's the best answer I can give you. But it's a great question because languages that are very popular, like JavaScript, have the same convention, which is why I tend to use double quotes as much as possible. Great question. All right. All right, so these are examples of data types. So let's see where these data types actually mean something by showing you exactly what it looks like when we have these mailboxes or these safe deposit boxes with values put into them. So let's consider the memory of a computer to be kind of like a table. And the table has three columns. The first column, I don't exactly know how I show up. I think it's over. This is your left, I think. All right. So the first column is the name of the variable. The middle column is the value of the variable. And the third, or the far right column, is the data type of that variable. When we want to create a variable and store something in a computer program, we do it with what's number 3 on the slide here. We give it a variable name and then a value. And in order to put a value into that variable name, we use the equal sign to put it in there. I'm going to show you all this in like ridiculously slow detail, okay? Now, usually we use we call the variables, we name the variables in something called snake case, which is that it's all lowercase and we separate words with an underscore. All right, so I'm going to show you some examples of this, but on the right-hand side, you can see that there's a variable named pi with the value 3.14, and the data type is float. Now, can somebody tell me why the data type is float? Is that the most appropriate data type?
Because it has the decimal after it.
Good. It has the decimal places. You know, full credit if you would have said fiddly bits, but you know, I'll give you a solid 9 out of 10 for saying that it has decimals. Very, very good. Absolutely. Now, Python, when I said it's like super dumb, it is actually smart enough to figure out that since it's 3.14, that is a floating point number. So it is smart enough. All right. So here we have a variable. The second one, the name of this variable is int. Is that the name of the variable?
Integer.
Yeah. So what's the name of this variable?
Population.
Population. Absolutely. I'm trying to, I lie a lot whenever I'm lecturing. Like so you have to get used to me. Never trust me. Never trust anybody. That's don't trust people, but just not me. I'm not trustworthy. So this variable has a name population. The value is 8675309, and the type is int, which means that it's a whole number, no fiddly bits. We've got that right. So let me show you how we create and store things inside of these variables. All right. This next one, the first line, is actually a line of Python. It says x variable equals 1. This is what we call declaring a variable. I am declaring the variable X variable, all right? And when I declare it, what I mean is I'm creating a variable in memory based on that information, all right? So based on the previous slide, all right, let's look at this. I'm going to create a mailbox. This row of this table is going to be my mailbox. It's going to be my variable, and it has 3 different things that define this mailbox. 3 different things. They are the name, the value, and the type. For number 1, it says X variable is 1. What is the name of that variable?
X.
Just like that. All right. It is this camel case. So very good. It's X variable. Very, very good. What is the value that you think we're going to put into that mailbox?
1.
1. And what data type?
Integer.
Are you sure? Could it also be float?
It could be a float if you put the 0.0.
Good. That's exactly it. If I would have put 0.0 there, it'd be a float.
So do you always want to do the point? Do you always want to like assume it's a float?
Oh, no.
No.
A lot of times you want to do an integer, and that's a long explanation why.
Okay,
And
yeah,
why
we
it's
have
not
to
as much super matter, but I'll tell you this much. Integers take a little bit of information, and floats take a lot of information to store in the computer. So in general, you want to use integers whenever you can to save memory.
Oh, I see.
That wasn't a long answer. That was a short answer. I don't
Yeah,
know.
that's pretty good.
All right, so there we go. All right, so let's call on some people here and or let's get somebody else to do this one. Line 2, we're going to create another variable. We're going to declare it and give it an initial value. So we're going to do line 2, and we're going to put it into this mailbox right here. So somebody else give me a volunteer. What's the name of this variable? Swastika.
Line slope.
Line slope. Good. All right. What is the
3.5.
value? Good. And the type?
Float.
Could it be a string, Swastika?
No, because it does not have the I don't know what do you call it, but
Perfect.
yeah.
You got it. You got it. It's missing those string things. All right.
Mhm.
Now this one's a trick question. Number 3 is a trick question. All right. Now number 3, I'm purposely being a jerk. All right. This is a variable declaration initialization. We want to put it in this mailbox. But somebody tell me where I might have screwed up here.
You open with a single quote and close with a double?
And Katie, I will tell you that is the sort of thing that's the reason why computer scientists have comb overs. You see how much bald head there is? It's because of that nonsense. All right. It looks for those little crazy small things and it changes them. All right. So we have to make sure that we consistently do this stuff. So good job. Very good. All right. So, but it is going to be a variable. Now I'm going a little bit too slow here. So I'm going to do this. I'm going to put input chars. That's the name. Capitalize it. Stinking Microsoft stuff. And the value here is coming in. And the data type is a string. Awesome. So everybody's got this. Now, I do have to tell you this. Okay. This is how we put stuff into mailboxes right at the beginning. But what do y'all think this does? What do y'all think it does? It looks so close to number 2 that what I think I ought to do is this. I think I want to do this. There might be a problem here. What's the problem?
A line can't have two different slopes at the same time.
Yeah, it's like having two safety deposit boxes that are box F3. Which one is F3, right? You can only have one name for one mailbox, one safe deposit box, in one variable. If I were to try to store something, the problem is I go, okay, what's the line slope? And the computer go, 3.5. And it will never be more than half right. All right. So no, we can't do that. What do y'all think this is really intended to do right here? This line slope equals 1.0. What do y'all think it was really intended to do?
Show the slope of a line.
Kind of. We're getting there. Line 2 declared a variable in this row, and it said the name of the variable is line slope. We're going to put 3.5 into that mailbox, and then Python figured out its float. Now this one says there's a variable named line slope, and I'm going to put into it 1.0. Here's what it's going to do. It's going to put 1.0 into the line slope mailbox, just like that. Y'all see it? It's going to essentially take whatever's on the right-hand side of the equal sign, and it's going to put it into whatever's on the left-hand side of the equal sign. What's on the right-hand side is 1.0, a value, and what is on the left is called line slope, which is a variable. So it's going to put 1.0 into the line slope variable. And I love saying mailbox, but I'm trying to keep it, it puts it in the mailbox. All right. So we can do a lot of things with this. Okay. We can do things like we can call a print statement. And if you'll excuse this, this won't actually work, but it'll get close. Print line slope like this. And could y'all imagine what this would do? It goes to where the line slope mailbox is, and it gets the value out of it. All right. We're going to see this, and we're going to play around with it a lot. I promise.
Wait, so which one is it going to print though? 1 or 3.5?
Good question. It goes in order. So if this was if these were lines of code and we went step by step, the first one gives us a variable called X variable, and it sets the value to 1. The second line would give us a variable line slope with the value 3.5. The third line would give us input chars with coming in, and that's what give us these 3 variables. But the fourth one would put the value 1.0 into line slope, and it would erase what was in there, and it would put 1.0. So
Okay.
line 5 would print out 1.0. That is a great question for me to go back over. I appreciate it. Swastika, question as well?
Yeah, it's a really dumb question, but does it matter what kind of brackets you use? Like, can you use the curly brackets or?
No, that's an important question. You need to use parentheses in Python. For most of this stuff, I'll let you know when to use square brackets and curly brackets and all that stuff. But right now, for most of the things I'm going to show you, we're going to have to use the parentheses above the 9 and 0 key.
Okay.
That's very, very important. Thank you for asking that question.
And you also mentioned that print line won't work. Is it because you didn't put quotes, or are we going to learn something else?
Oh, because there's more to it than that, and I'm being super lazy in showing it. I don't want to show the complicated version of that print statement to make it actually work. So I just wanted to show you that to show that we can pull values out of the mailbox. So it was syntactically incorrect. But we're going to see it in just a second. All right. So we have seen the very beginnings of variables, but we also need to see how we might get values for those variables. The jokes are going to be very, very bad in this class, okay? I am a father of 3, and the dad jokes will be coming, all right? Let's learn this together, all right? So I want to stop coding here. And I want to do this in rappel.it with you. And I want you to start seeing some Python code for me. All right. So I'm going to see if I can share my Python window here. All right. All right. So what I'm showing you is a very, very simple program in Python. But there's a lot to this. There's a whole lot to this. I need to talk about Repel.it to show y'all what coding looks like. And for the sake of this, I'm going to go ahead and erase what's here. And I'm going to add some very simple pieces of code. All right. First off, I'm going to do this. Hashtag. All right. I type 2 lines of code into my window. And what this is going to do is it's going to print out my name and the date and a program to a description. And it's going to put that. And when I hit run, it's going to put it in the right-hand side of this window. It didn't work. Somebody help me out here. Line 1. What is line 1 of this program that I'm presenting? What is it supposed to do?
Do
It's
nothing.
about-
Just a comment.
Yeah, good. It's a note, it's a comment. It's not supposed to do anything. This isn't an instruction to the computer. It's actually an instruction to programmers. So this is very, very useful, y'all, because there's a lot of stuff that I code and then like 3 weeks later I forget about and I have to come back and I'm like, what is this? Who did this? All right. And I mean, some of it's a decade old. I use code that I wrote in college 20 years ago, right? So it's helpful to put some notes in here. These are comments. They start with a pound sign and they don't do anything. So when I hit run, it's supposed to output all the stuff from the program over on the right-hand side. It did not do it. So let's add a couple of lines here. All right. I am going to do print, and then I'm going to put testing input. Just like this, I'm going to hit run, and now it worked. It put that little bit of stuff on the right-hand side, and it's there, okay? So I want you to get here with me. Right now, I want you to catch up to me in repel.it or repl.it, open up a Python program, and I want you to add these 3 lines of code. Technically, there's 4. I put one little empty space here. And when you hit run, it should say testing input on the right-hand side.
I have one question.
Hit me.
Is Python like indent sensitive? Like
It is
basis?
very indent sensitive. And
All
right now, we're not going to do anything. So that's the next chapter when we do the if-thens, the iffy type of programming. We're going to learn what those indentations do.
Okay.
But it's actually, unlike some languages like Java, JavaScript, C, C++, that it really doesn't matter where you indent. This one's very important.
Yeah, Java didn't at all.
Yeah, Java, you can put it all in one big line if you want to. And Python's a lot more detailed. So is anybody having an error that I can help with? You can add it to chat, and I can just tell you what it is. So I want to tell you a couple of things while you're typing in, just to make sure that we get there. First off, you'll notice that this window on the left-hand side where we're typing, this is the code editor side of it. It has what's called syntax highlighting. Now, remember that the syntax are the rules of the language. Well, based on what it thinks should go there, it's actually highlighting the colors of the letters to be what we would expect it to be. So as an example, that isn't where it says John W. Burris. It isn't black. It's actually gray. So when I start typing here, it's black, right? But above it, it's gray, which means it makes all of the comments gray. Where it says print, this is a very special thing called a keyword, which means that it's built into Python. It turned it purple. In strings, it turns red. This can help us understand if we've made a mistake. Excuse me. Made a mistake. Because if I forget that quotation mark right there, you'll notice two things. First, it gives you a red squiggly line that says there might be something wrong, but it also gives us a hint with the syntax highlighting that there might be a problem there. All right. All right, so I want to do a couple of things real quick. I want to try to make a variable x equals 5. Okay, that should work. That gives me a variable called x that holds the value 5. Don't type this with me because I'm just doing absolute nonsense. And then I'm going to take a new variable called print. I'm going to set print equal to 3.75. Does somebody here see something that might be a problem?
Well, you wouldn't assign print a number.
Absolutely. Daniel, you raised your hand. What were you going to say about it?
Same thing.
What was your clue?
They're both purple.
Purple. That is exactly what I wanted you to say. The fact that there's a purple word there means that we picked something wrong. All right. So if we try to name a variable something and it shows up as purple, we can't do that. There's a lot of keywords and those keywords show us purple. So I'm going to go ahead and erase what I did there. I'm going to add this line. All right, all that stuff. Now I want you to go ahead and type this in with me. I want you to go ahead and type this in. And I'll explain what this stuff does in just a minute. But go ahead and get caught up with me. These 6 lines of code. So I've got some people taking it over here, and I think they said it was kind of hard to see. So let me make it a little bit. I don't want it to wrap. So wrap, W-R-A-P. It would be pretty cool if they wrapped it, but let's see. Maybe this is a little bit more viewable.
How come you don't have to wear glasses, Dr. Burris?
I do on occasion whenever I get eye strain, but I've got 20/20 both eyes. The only one in my family that doesn't have eyeglasses or LASIK. So, but I'm getting pretty old, so I have a feeling it's going to catch up with me. Carter and Cole, I've got news for you. It comes from the mother's side. Enjoy the hair while y'all have it.
I luckily got the good eyes.
I have one question.
Hit me.
Whenever you printed that string where the X is modulus S, how come the modulus S didn't come up?
Oh, I need to talk about it. That's what I'm going to explain next.
Okay.
We're going to go line by line and talk about it.
My bad.
All right, so I'm hoping everybody's here. If you need more time, just keep on going. You can come back and check the video later. All right, line 1. It's important. What does line 1 do?
Comment.
Yeah, comment. Doesn't do anything.
Yeah.
Line 2 doesn't do anything. Now, line 3, it's blank, which is okay. You can put some spaces between your stuff. Okay, you really can. Now, this is very important because we understand this from English, writing in English. Have you ever read a book where they don't put enough paragraphs? Like they don't separate their junk and it's just like this one big long stream of text. And it's like the same thing happens in code. And the way we kind of make a new paragraph is we can put some blank lines in there to separate it out a little bit. Okay. So line 3 is a little bit of space. Line 4, what does it do?
Assigns a number to a variable.
Oh, wait, no, that's line 5. What about line 4?
Oh, I'm sorry. Just prints a string.
Print a string. It says testing input. Now, I want you to kind of use your deductive reasoning here and realize that when it says print testing input, what that means is Python knows how to print whatever is in those parentheses, right? Print is a command. It is a line of code that gives an instruction to the computer that says print out whatever in the parentheses after it. What's in the parentheses after it? Testing input. Now, if I'm trying to learn how to code, I'm generally going to try to break everything. So if I can print out a string, can I print out? What's this going to do? Yeah, it just prints out whatever. Whatever is in those parentheses, it prints out. Okay, so line 4 prints to the console, that thing, that black square on the right-hand side. It prints out whatever's in the parentheses. Since we had a string in there, it's going to print out the string testing input. All right. So let me see if we've got a new person. What about line 5? What does line 5 do? Give me as much detail as you can. Do I have a brave soul that's willing to say it?
Line 5 assigns a number to a variable.
Good. What's the name of the variable?
X.
What's the value?
5.
What's the data type?
Integer.
Perfect. That's everything. That's everything. Those are the big 3. Look at Cole. He's like dogging Carter for being the nerd in the class. All right, good. So absolutely, those are the 3 things that define a variable. So very real in the computer. This is not me just being like this weird analogy. Inside of that computer right now, it has created a mailbox and named the mailbox X and said that mailbox is going to hold integers, and it puts the number 5 into that mailbox. All right. That is what happens with that line 5. I clicked off of it so I can't see it. Very, very real. That's what happened. All right. So the next one. I am not going to make anybody do this. Okay. I'm not going to ask you to answer what this does, but there's a lot here. Inside of Python, as we start to code, we're going to be doing a lot of coding by example. We're going to go look at, well, how do you do this? How do you do that? How do you do this? And this is kind of like I printed out, like I looked for how to print out the variable X. But suppose I didn't have this, all right? Suppose I didn't have this. Right now, can somebody think of a way that you would try to print out whatever's in the variable X? You think this could work? It works. It works. All right. We have to be careful. We have to be very, very careful when we're coding. To follow examples, but to not overcomplicate things. All right. I'm going to go back to this. Let's look at it. Oh, that's not it. As we analyze this, there's a lot here, right? This print statement is going to print whatever is inside of these parentheses. The first thing it prints out is X is, and then there's a %S right there. And then it follows with a %X. I will tell you that this is doing something called matching, which says it's going to print out whatever that value is, and it's going to match it to this X. And I'm not going to explain it any further because right now I want you to use your Sherlock power. All right. Now, inside of all computer science, it's very important that you understand what Sherlock power is. All right. Sherlock power is the idea of deductive reasoning. And I have to point it out right here because I'm about to ask you to do something that's way harder, way more difficult, way all this stuff. And I need you to figure it out. Okay. I need you to challenge it because in the way Sherlock thinks is he has this statement which says once you eliminate all possibilities that can't be, whatever remains is the truth, right? And that's what deductive reasoning is, right? Deductive reasoning says there's all these possibilities and I'm going to start taking away all of these things that are wrong and whatever's left is there. Inductive reasoning says I'm going to look at what I've got and I'm going to try to figure it out, right? I'm going to look at what I have and figure out some knowledge. In computer science, we'd use Sherlock power. All right. So if anybody here is a Sherlock Holmes fan, that's what we're doing. I'm sorry, y'all. I'm sitting right next to a printer and it's just really loud. Give me 1 second. All right. I guess it's over. All right. So I'm going to go back to this repel.at with the thing that I'm going to say is Sherlock Holmes power. All right. I want you to type this line 5 and line 6, and I want you to get synchronized with this program. I want you to get here at home.
Can you share it?
Oh, I'm sorry. Thank you. I want you to caught up with this. Oh, shoot, y'all. I'm sorry. There's something in here I didn't mean to be here. Sorry, right there. That's what I want it to be. All right. I know we're kind of running up against time, so I apologize. I need to do something real quick. Line 1 is a comment. Not going to keep going on about it. Doesn't do anything. Line 2 is a comment. Doesn't do anything. Line 3 is just kind of, we'll talk about sexy code in a little while, but it's just some making it clear. Line 4 prints the string testing input, but line 5 is new. Line 5 is definitely new. Now, I want to tell you, as you type this out, it has to be exact. Computer science is all about the details. You have to be right on. Don't assume that you can put a space anywhere. You might not be able to. Don't assume that you can go down to the next line. Don't assume anything, right? So try to be as detailed as possible. Very, very detail oriented. And I want you to type it exactly as it is. Name equals input, open parentheses. It needs to be exactly the same, all right? But let's use our inductive reason. Let's use just our logic here, our human ability here to reason. Line 5, name equals something that looks like a variable declaration. All right. Now, Katie, I'm going to challenge you here. All right. Line 5 looks like a variable declaration. It says name equals input. What is your name? I'm going to ask you this first question. What do you think, Katie, what is the variable name going to be from line 5? What is the name going to be?
Input?
Very, very good idea. Very, very good idea. Now we're going to name the box. And I was trying to be like overt in it. It's actually going to be name. So I should call it name. So I was trying to be a little cheeky there. All right. Now, based on the context, so I'm not done with you, Katie. Don't mute. You're not done.
Oh, man.
You're the sister. You're going to get picked on. All right. No, based on the context of line 5, what is the type of the data going to be?
A string?
Absolutely. All right. Just based on the context of it. But Katie, we know the variable is going to be called name. We know the type it's expecting is going to be a string. All right. Where do you think it's going to get this string from? Just guessing. I haven't taught you this at all. It's totally okay to be wrong.
I don't know. I would have assumed from some other line, but I guess that input word must do something.
That's it. That is it. Perfect, perfect, perfect. The input line is the clue. All right. So it's going to pull information in from the user that they type in, and it's going to put it into a mailbox that's named name. That's what it's going to do. So let me show you what that looks like in practice. Outstanding, Katie. Very, very good job. All right. I promise to only put high pressure on my relatives unless you volunteer to be to answer. Okay. So let's look at what it's doing. On the right-hand side, it says this: what is your name? Inside of parentheses. This input line, this keyword input, is going to include what's called a prompt. And this is a string. I intentionally put single quotes, but it could also be this with double quotes. All right. And what it's going to do is going to print out that string. And right over here, it's just going to wait. What is it doing? Line 5 created a mailbox called name, and into it, it put something the user inputs. And it says, what is your name? And then it has this little square. Y'all, this program is running, but it's not doing anything. What is the program waiting for?
Your input.
Absolutely. It's waiting for the input. So I'm going to put John over here on the right-hand side. I'm going to click over into the console. I'm going to hit John, and we hit enter. And now you'll notice at the top, this button isn't, it's stopped. It's ended. The program is done. You see a little red prompt here. It's done. All right. So let's analyze what just happened. Swastika, question.
Why do we have that percentage s and percentage name? Like, would it have worked if we just wrote hi and name?
I don't know. We'll have to try it out. That's a great question, Swastika. That's exactly the sort of thing that I want you to try out and try to figure it out and break it and see what the syntax is. So it's a great question. And we're totally just going to try different things. All right. So what line 5 did is it created a variable called name. And into that mailbox, it put whatever the user entered. And I put in the name John. So it made a string. There's a mailbox somewhere that has the name, and in the value, it has John. And as the type, it has string. Just like that. All right. Stored in the value. All right. So line 6, it prints out that same weird, complicated line. It says hi, then %s, then another %, and it says name. All right. Now, Swastika had a good question. Is there an easier way to do this? I don't know. Let's try this. Swastika, what you've helped us discover is our very first error. It says, no, something's wrong here. So I can't figure it all out there. And it says not all arguments converted in string formatting. So it seems like we may have a problem. So it seems like, no, we need it this way. All right. So let me explain what these characters do. Line 6 is a print statement. It prints out whatever is inside of these parentheses. In the parentheses, it has this. Hi, comma, %s. Now, here's what that is. This %s is called a placeholder. And what it does is whenever I put the %s there, it'll match that to what's called an argument after it. So it says %s. It's going to replace that with the first variable that we put after it. And I'm not going to talk a whole lot about it, but let's see it. I even caught my mistake. It's almost like it prints this string, but it replaces this %s, this placeholder, with whatever variable is after it.
So I have a random question. Since we learned that % symbol stands for like modulus and it's like remainder with like whenever we're using numbers, does that mean different like characters can have different meaning?
Yes.
Meaning
depending
like,
on the context.
Like, does that mean like we could put like another 2 letters there and then match them on the other side and it would bring out the same thing?
Possibly.
Okay.
Absolutely. Okay, absolutely. You can put another %s and it's going to look for another variable. We're just not going to do that right now, but absolutely. But I want to keep it like super straightforward with this example. So, and that being said, it should still be confusing. It should still be a little confusing, and I want you to play around with it. But are there any more questions? That's a very, very good question, Zach. Very good question. Any other questions about this?
Can you use any letter in place of the lowercase s?
No, it needs to be an S. And we're going to follow this example as closely as we can. Very
And
good
it has
question.
to be the % sign too.
Yes, it has to be %s. What it's saying is that's a string. It's a placeholder for a string.
Oh,
And
I
I'll
see.
get to that. I'm going to do a lecture that's going to be kind of long, and we'll get into the details of that syntax. But for right now, that's where we're going to go. All right. I promised that we were going to be a little bit short. So and we're getting close to our hour. Let me do the next bit. All right. Just for the people, if they're looking at it I'm going to put this PowerPoint online. This is just what we went through. All right. One last thing. We can do math inside of Python. I'm going to put an example up here so that we can see it together in like active learning instead of just lecturing. But we've got all the PEMDAS operations, parentheses, exponent, multiplication, division, addition, subtraction. And I'm not going to overcomplicate it. All right. Let's look at this right here. And you don't have to type this with me. You can totally just watch along. All right. this is actually not ultra easy. Wait, I've messed up. How can I mess this up? What did I do? I'm sorry. All right,
Is-
there we go. Sorry about that. All right, let's look at this line of code. Let's step through it together. Line 1 is a comment, doesn't do anything. Line 2 is a comment, doesn't do anything. Line 4 creates a variable, and what is the name of that variable?
Input.
Not quite.
Name?
Cole, did you say X? Pretend that you said X. All right.
I definitely said that.
All right. So the name of the variable created in line 4 is X. All right. And into X, it puts the input entered by the user. In my example on the right-hand side, when I ran this piece of code, what value did I put into the variable X?
Seven.
Absolutely. 7. Now, line 5 does something weird, totally weird, okay? Line 5 is an assignment statement. It takes whatever's on the right-hand side and puts it into the left-hand side. All right, so it does a little bit of math on the right-hand side. It says int x plus 5. What's the value of x?
The value that we give.
Absolutely, which was 7. Absolutely. So it takes 7, adds 5 to it, and puts it into a variable x. Let's change this up just a little bit. I'm going to make it easier. I probably should have thought of this better of this. So I'm going to create a variable y, and we're just going to print out y. That should be a little bit more clear. I apologize. I should have done that example from the beginning. So, all right. So let's analyze this line by line. 4, it creates a variable x. It gets the input from the user, and it puts it into x. Line 5, it creates a variable y, and it puts into it x plus 5. What value goes into the variable y?
Like the answer of x plus 5.
Absolutely, which is
12.
12. Absolutely. All right. So here's the thing. I'm about to give you an extraordinarily difficult challenge that you can do. And this is just, it's not an official assignment, but I want you to try to do this. And you can do this. Like you literally can do this. All right. I almost hit end call instead of stop presenting. Let me go back here. I want you to write a Python program to input a temperature that's in Celsius and convert it to Fahrenheit. All right. Now, here's the thing. This is a huge step forward. It's going to be a challenge, but I want you to think about it. And I want you to think about it as though you're telling a really stupid computer how to do this with what we know. All right. I'm going to step through the first steps with you. I'm going to step through the first steps. Input Celsius, convert to Fahrenheit. All right. The first thing that I'm going to do, I've already got a mistake here. This is a program to convert Celsius to Fahrenheit. All right. What? Put some autocomplete there. To get this job done, the first thing that you have to do is input a Celsius value. I don't even know if that's how you put that. That doesn't look right. Celsius? I don't know. That weird way to do temperatures, right? Input a Celsius value. Then calculate the Fahrenheit value. Now, what's crazy is I know how to spell Fahrenheit well because it's, that book. All right. And then we want to print the Fahrenheit. All right, we have to start thinking in these step-by-step ways of how we're going to tell these computers to do this. Now, who here knows how to convert Celsius to Fahrenheit? Nobody. How do you figure it out?
Google.
Google it. All right, now here's what I want you to, I do not want you to Google Python code to convert Celsius to Fahrenheit. All right. If you do that, I will come through the internet and smack you in the face. All right. That's not what we're going to do. We're going to Google the formula to do this. And we're going to try to figure it out. All right. We're going to try to figure out how to do this math. We're going to try to figure out how to do the input. But y'all, you know how to do this. You do know how to do this. I promise. You know how to create a variable. You know how to get the user's input. You know how to print a variable. You've already got an example of that in this code. All right. The only thing we have to figure out is how to do the conversion, the math part. And you can do that. I promise that you can do that you can figure it out. All right. So stick on it. Try to figure it out. I am going to give you a little bit of a time where I'm going to stop recording. It's kind of the end of the official lecture. But if you want to hang out and try it and share your code with a class, see where we're at, we can totally do that. I can stick around for another 20 minutes before I fall asleep. So we should be good. All right. So I'm going to go ahead and stop recording, but you can do this. Can do it. Keep working on it if you can. All right. We are not recording